Write and graph a system of linear inequalities. At her party, Alice is serving pepper jack cheese and cheddar cheese. She wants to have at least 2 pounds of each, and she wants to spend at most $20. Pepper jack cheese, of course that would be, sells for $4 a pound, and cheddar cheese, of course, sells for $2 a pound. Well, we already know the price per pound. What would be the unknown? How many pounds of each? Yeah. So look down at the graph. I bet I've already kind of picked for you which one's going to be which. So which is going to be which here? Let X represent the number of pounds of pepper jack. Okay. We can abbreviate here because we're not writing sentences right now. We're just describing our variable. And then Y then, of course, would represent the other type of cheese, which is our cheddar cheese. So pounds of cheddar. So it would not matter which one's on which axis. It's just that I happen to just pick it for you. You could have reversed those if you wanted. It still would have worked out that we get the same solutions. It's just our graphs will look a little bit different is all. Okay, and she wants, what other piece of information is important? She wants at least 2 pounds of each. Okay, again, we already know how much the pepper jack cheese sells per pound. We know how much the cheddar does. So all we need to really do right now is say, okay, she's going to buy some cheese and she doesn't want to spend any more than $20. What inequality statement can we set up for that? Todd?
4x plus 2y is less than $2.
Okay. The pepper jack cheese is $4 a pound, so 4 times how many pounds you buy should tell you how much money she's going to spend on pepper jack cheese, plus $2 per pound for cheddar. 2 times y would be how much money is spent on cheddar, and then now we need to say she doesn't want to spend any more than $20. So what did you say, Todd, was the inequality symbol? Is less than or equal to 20. Okay. So there's one of our inequalities. But there's also a couple of other restrictions. She said she wants to do what? She wants to have how much for sure? 2 pounds of each, right? Okay, so what could we do? We're going to have 2 more inequalities then. Okay, one of them is going to be our pepper jack. What would that one? What would the pepper jack having to at least 2 pounds of pepper jack cheese? What would that look like as an inequality? Jacob?
X is greater than or equal to 2.
X is greater than or equal to 2. And then at least 2 pounds of cheddar, Courtney? Y is greater than or equal to 2. There we go. Okay. So now, what kind of a line do we have for that one? That's a vertical, isn't it? And will it be solid?
Yes.
Okay. And this one's a little, when we talk about vertical, it's a little bit different thought process. We can't talk about above or below, we got to talk about left or right. Well, we want more than 2 pounds when we say greater than, so it should be shade to the left or to the right of that? To the right, yeah, so we're going to shade to the right. Okay. Why don't you go ahead and do that one first? Let's get that one on there. It's your vertical line going through 2 on the, starting at 2 on the x-axis and going up. You don't even need necessarily make any points. You can just use your ruler and you can say, okay, I'm going to put a vertical line at 2 on the coordinate plane. Oh, by the way, you probably better do some more numbering here, right? Looks like I'm going by halves on the x-axis and by 1s on the y-axis. So we probably also want to continue numbering to make it easier to follow and read. And shade to the right. Okay. Use red for that one. Okay, how about our, let's jump down to our y is greater than or equal to 2. What do we have here? Kind of a boundary line. That's a horizontal one, isn't it? So we have a horizontal boundary line, which will be solid or will it be dashed? It will be solid, because we want to include the 2. And now we can talk above and below. Would we shade above or would we shade below? Above. Okay, so again, with your ruler, and starting at 2 on the y-axis, draw yourself a horizontal line. And shade above. Okay, use green for that one. This is where we want to shade kind of lightly because, but if you already see that there's some overlap region in that area, you can shade that a little bit darker right now if you want. Okay, so right now, if we were to stop right now, we would say the solution region is right here, isn't it? Because there's where we have the overlap from this part. Okay, but we have one more to do. We need to also now, let's get our 4x plus 2y is less than or equal to 20. Let's get that into slope-intercept form. So we'll subtract 4x. Change that to add the opposite. Divide by 2. And see if you agree with me. Before I go to work. Okay, use the same new name for our inequality. Okay, so our b value is 10, and our m value is -2. Okay, and we're going to be really careful though because the scale on the axes does not match. It's going by halves on the x-axis. It's going by whole by ones on the y-axis. So when we're graphing this, we have to be careful. Okay, so we're going to start at 10 and put our y-intercept. We're supposed to go down to, that would take us down to 8, and we have to go over how much? 1, which is actually how many grid lines? 2 grid lines. So we have to go down 2. So in other words, you think of it like this: we're going down 2 cheddars and over 1 pound of pepper jack, and the pepper jack is going by halves down there. So we keep doing that until we have a whole bunch of points to help us out here. Should be able to eventually land on the x-axis, I think. And now, this one, don't need to extend beyond because there's not such a thing as negatives. So this one we can just go from the y-intercept to the x-intercept. Okay, and we didn't decide here if it should be solid or dashed, but should it be solid? Okay, drew mine, okay. Should we shade above or below? We should shade below. Okay, so this time, we're shading, this is our boundary line, we're shading this region. So we have all kinds of shading going on in this graph. The whole graph ends up being shaded. But where do we want? Where they're all shaded, where it's triple shaded. So where is that? It's just this nice little triangular region. I think I can do it with my yellow here. This is where all of the shading ends up in this triangular region right here. Not a very big region. But I'm sure that's $20 to spend. So we would expect it not to be very big, right? Okay. Now, I'm gonna let us change this to give 3 possible combinations. Okay? We'll have a lot of space on Because we don't just write them as ordered pairs, how do we write them? Not sentences even, I'm not gonna make you do sentences, but what do we have to do? We don't say 6 ordered pair 6-3, we would say, and we'd say 6 pounds of pepper jack, 3 pounds of cheddar cheese. Now, I'm not saying that's one of them, I just use that as an example, okay? So, somebody give me a possible combination here of what she could do. She wants at least do 2 pounds of each cheddar cheese, but she doesn't want to spend more than $20, so what could she do? Jared?
2 pounds of pepper jack and 6 pounds of cheddar.
Okay, I'll let you call pepper jack, PJ. 2 pounds of pepper jack, and what was the other one? I'm sorry, Jerry. 6 pounds of cheddar.
Yep.
Okay, and we'll let cheddar be CH. Okay. So she can buy 2 pounds of pepper jack and 6 pounds of cheddar. That happens to be this point right here, doesn't it? And why does that point count?
Because it's on.
Because it's on the boundary line, and all the boundary lines are. All the boundary lines that go through that point are solid, so it can count. If one of those boundary lines was dashed, could we use that point, do you think? No, we couldn't, no. Okay, give me another one. By the way, can she buy parts of like half pounds of cheese, you suppose, and quarter pounds? Probably. Okay, great.
2.5 pounds of pepper jack and 3 pounds of cheddar.
Okay, so that'd be right here. That looks like a good one. 2.5 pounds pepper jack and 3 pounds cheddar. Okay, one more. I cut it down to 3. Todd.
3 pounds of pepper jack and 3 pounds of cheddar.
Okay, 3 pounds of each. That would be this point right here. So 3 pounds pepper jack and 3 pounds cheddar. Okay. So now, do you think you can do these application problems better? Yeah.